Okay, I think we are back here. And it's my pleasure to replace the Spanish colleague Esther Paniagua, who unfortunately has worked on the organization of this panel and who unfortunately could not make it and could not be with us today. It is my pleasure to be the moderator and Fabio Turone, as I said already. I am hosting the chair of the conference organizing committee, and I'm a science journalist based in Milan. We have today a very impressive lineup of speakers who will now talk with us about how the science journalism community should expect artificial intelligence to affect and to shape in somehow our future work. It is my pleasure to have here today with us our colleague Mico Tatalovic, who is a news editor from Research Fortnight in the UK. If you can please show the speakers, I ask our technical staff in Padova to show the people so that we can see their faces. They're all connected, but depending on the Zoom visualization, I think you are now only seeing me. Anyway, I already announced Mico Tatalovic, which I cannot see currently, but I know he's online. Giovanni, can you please show all the faces to everyone? All the speakers. We also have with us Professor Charlie Beckett, from the head of the Polis project at the London School of Economics, Department of Media Communications. We have Professor Harry Collins, the professor of sociology at the Cardiff University. We have Professor Fabiana Zollo, who is a professor at the Università Foscari in Venice. She's exactly, I'm not sure I can describe you work on data as a scientist, basically. So we have several perspectives. I think that it might be interesting to start from Professor Collins' perspective. He's a sociologist, and he will start addressing the question about how what kind of attempts were made to make artificial intelligence do science first. So please, Professor Collins, the floor is yours.
Well, thanks. In fact, I think I'm probably the least interesting person on this panel because I don't know anything much about attempts to replace traditional journalism with artificial intelligence. What I know about is, as our host said, attempts to reproduce science with artificial intelligence. Now, of course, the one question bears on the other. And what I can tell you is there's lots of ambition among the artificial intelligence community to replace the work of scientists with intelligent machines. But as I'm sure you'll all know, there's huge amounts of hype in the artificial intelligence community. And there's a sort of carapace of public descriptions of what artificial intelligence can do, which doesn't necessarily reflect what artificial intelligence really can do. Though I've spent most of my career writing about natural science, a lot of it on physics. For example, just so you know who I am, I spent 45 years hanging about with the people who discovered gravitational waves up until the moment they discovered it and a little while afterwards. And I've written about 4 books describing that, and I've written about a lot of books altogether. But 3 of the books I've written are about artificial intelligence and its capabilities. So I know a little bit about that too. So a early attempt to computerize science was a program called Bacon, invented by Langley and Simon, which they said had rediscovered Kepler's laws of planetary motion. But in my view, they made the typical mistake of what they did is write a program that if you fed it with all the data that we now agree was, that Kepler had, that we now agree is good data, it could do some manipulations with this stuff and get the equations out at the end. But the real art of science is working out what's good data and what's rubbish. And that's done with human interaction. It's not done by data analysis, except perhaps in certain fields where the methods and the data are already agreed. I mean, you can probably do it with something like medical drug trials, where everybody agrees how you should go about it. There's not much doubt about when a medical drug trial has been conducted properly. And this has led to a great enthusiasm for meta-analysis in science. So you put all the drug trials together and produce much better statistics than you would do from any single drug trial. But for most science, or most innovatory science, most new science, most controversial science, where people are still disagreeing about what counts as good data and what counts as nonsense, this won't work, because it would be a matter of rubbish in, rubbish out. You can aggregate all the bad studies and you'll get one huge, highly statistically significant, but completely wrong result. Let's take something like the discovery of gravitational waves, which I know a lot about. Before the final triumphant discovery of gravitational waves in 2016, or the announcement was in 2016, there had been half a dozen claims to have discovered gravitational waves over half a century. But eventually they were all consigned to the waste bin of science as a result of discussion and agreement among scientists. And if you did a meta-analysis of all those results, what you get would be just silly. Now, that seems to me to reflect in some sort of indirect way on what can be done with computers trying to replace journalism. It seems to me that I mean, I know there's a lot of stuff that goes on in journalism which is just analyzing press releases and so on and so forth, but I don't take that to be serious journalism. I take to be serious journalism where people are trying to get themselves to the frontier of science and make some, develop a real serious understanding of science. And it seems to me, there seems to be no warrant to think that that could be replaced by artificial intelligence if artificial intelligence cannot do science and if science is based on agreement. I think this is a vitally important distinction, because if we're not very careful, if we do too much replacing of this kind of science, which is done by scientists getting together and talking and disagreeing and agreeing and eventually hammering out some sort of acceptable output, we're going to wind up replacing science as it's done with social media agreements or internet agreements with collections of likes and dislikes. And that will be appalling for our democracy, because science represents a very important check and balance for how pluralist democracies work. Will that do as an introduction? Okay. We've frozen.
I'm sorry. There was a little glitch, technical glitch. So I thank you very much for being very even short for the time allotted. I will now ask Mico Tatalovic, who I don't see in video. I know he's there. Are you there, Mico? Okay. Mico Tatalovic is a colleague science journalist, currently news editor at Research for Fortnight, and he has been a fellow at the Knight Science Journalism program in Boston at the MIT, and he has been asking, from the perspective of a science journalist, what's the impact of AI, automation, and algorithms in science journalism. So please, Mico, the floor is yours.
Good morning. Can you hear me okay, Fabio and everyone?
Yes, we can.
Yeah.
Great. Okay. So yeah, I'll talk a bit about AI and automation and science journalism in particular. And this is sort of related to my research project that I've done while I was at MIT. So this is just a quick summary of what I found. So I spent a year kind of looking into this as part of my fellowship. And I think that artificial intelligence is already changing the media landscape, but talking to colleagues from around the world, I found that science journalists are often not really aware of all of the sort of changes that are happening and the implications for their work. Obviously, if we do develop these AI bots that can do our jobs, then our jobs will be threatened. Whether that's the case already is up for a debate, but I think it's important to realize that there will be implications for jobs and for the way we do our jobs. I think an important thing to remember is that if we deploy this technology in a way that's helpful to us, I think it can kind of help science journalism, enrich it, and make it and make our jobs easier rather than more difficult. So those are some of the sort of takeaway points from my research, and now I'll go into just showing some examples of what this technology can do. So I think in general, we see lots of media reports, and some of these are no doubt sort of overblown. But it seems to be that AI can do all these amazing things, such as do law, fly planes, even do surgeries, perhaps even better than humans, apparently, according to some of these studies. And I think in arts and media as well, there are ever more ambitious projects. So AI that writes a novel, BBC using AI to direct and produce their shows, or AI writing music, apparently as good as human composers in some cases. So here's the big question on everyone's minds in journalism: is will our jobs be taken over by AI robots? So these are not actual physical robots, but software. And I think if you look at the examples over the last few years, there are lots of examples of AI technologies. Well, they're not always fully AI, but basically automated software that writes news stories. And some of these are sort of some of the very prestigious newspapers, such as the Washington Post. So they actually already use automation to write their stories. And here on the screen, you can see a couple of examples of these stories. One of them is reporting on, I think, football results or sports results. Another one is on financial reports. If you read them, that they're actually, there's nothing sort of necessarily strange about them. They read like proper short little news stories. And some of them are about science as well. So an example from a few years ago is this bot that reports on, it automatically reports on earthquakes in California. So I guess these examples show that some of this is already happening. So these bots are writing lots of news stories. And that brings a lot of interesting questions, I think, for science journalists. So for example, this LA earthquake reporting bot made a mistake a few years ago, and it accidentally tweeted and reported about an earthquake that actually happened 90 years ago. So this is quite an interesting thing, that we often think about this technology as sort of being better than humans, but it can also make mistakes based on what we feed it, based on the data and the algorithms underneath it. But I guess what this example shows is just that automation is already being used in newsrooms to report on stuff, and some of this stuff is things that science journalists would report on, such as earthquakes, and that it can have sort of maybe unintended consequences sometimes. So the use of technology will be something that we'll need to monitor. We'll need to have, I guess, editors and producers who will be able to oversee this and understand how to fix things if things go wrong. Now, often people think that science is too complicated for AI to automate. But actually, there's already software out there to write research articles automatically. So this is one example. Side note, they have a manuscript writer. And you can see some quotes here from people who use it, who say that it saves them lots of time using this software. So this just takes all the information from a scientist's computer about their data, about their research, their references, and it kind of just writes the paper for them, and then they can edit the paper, which means that it just saves them time. This is an example from Science News, if you want. So this is a website called eScience News that looks like any other science news website. Lots of interesting news about all sorts of types of science from different beats. But the interesting thing about this website is it doesn't have an editor. So the editor is actually a fully automated artificial intelligence software, which uses all sorts of different, I guess, basically lots of different ways of deciding what to run and how to present it on this website. So, you know, if you're interested in automated science journalism, it already exists. So this website kind of does that. It doesn't produce its own content, but the way it presents it and curates it is all automated. And there are ever more sort of papers from academics who look into automating actual science news as well. So this is an example from colleagues in India and Belgium, I think, from a couple of years ago. And they've designed an algorithm that can basically, it takes your paper and it provides you with a headline for your science blog or science news about that. So it kind of understands or tries to understand what paper is about, and then provide you with a jargon-free headline for a story about that paper. I think you can, if you Google this, you can see the example here at the bottom of the screen, or what it looks like. So you can try it on different papers that you're reporting on and see what headlines it suggests. So yeah, I found that there are quite a few different programs that try to automate pretty much every step of science, media workflow, and some of it is in science. So, you know, you can, you have all these bots that are writing things. You have fact-checking bots. Some of them are really amazing that can sort of fact-check even broadcast a broadcast of some news event in real time as it happens. And then there's sort of automated video production where the videos are done for you based on keywords. And even social media promotion of stories later on can be automated. So you have various software such as EchoBox that will kind of do the job of editors for them. And I think where AI and machine learning help is that they can crunch a lot more data and information than any human can, and decide on what to post and when to post it and where to post it for biggest impact. So lots of these AI tools are already being used, and many more are being developed. Yes, this is just an example of EchoBox, where, you know, they claim that they're emulating what a team of editors would do if they had enough time and big enough whiteboard to observe all the stories, all their history of posting, all possible places they could be posted, and then based on that makes a decision that's apparently better than the decision that a human could be. Now, you know, I'm not sure if this is true or not, but this is their claim. Automated fact checking. There are already many tools for that as well. There's an example here of a US science journalist who actually, she is a professional fact checker. So she fact checked a news story, I think it was about climate change herself. And then she used one of these online tools, automated tools. And, you know, she found that she spent 6 hours to do her fact check, whereas the AI tool only took 11 minutes. Now, at the time, this tool wasn't as good as her fact checking, but she said that, you know, in the future, with so much fake, so much content, we will probably need AI fact checkers to be our ally against fake news. And I think this is probably something that will come our way soon, because there's no way that an AI tool cannot do things quicker and potentially better than human, especially with something like fact checking that just depends on checking background information and data. So there's about interesting projects out there. This is Science Surveyor, something developed at Columbia Journalism School, where they used algorithms and machine learning to analyze papers and provide sort of user-friendly interface for journalists. So the idea is that if you're reporting on a paper, you can feed the paper into this AI tool, and it gives you lots of context and background information about that subject, about that paper, tells you how reliable this paper is. So this is a sort of, I guess, a helpful tool that could maybe help journalists better report on science. So there's so many different applications. You could imagine automating science news writing and editing, providing context and creating instant experts, so you don't have to be experienced science journalists to know whether a paper is reliable or not, as was the example with this Science Surveyor example. Improving science writing skills. There's now AI software out there that can sort of mimic different writers. So you feed it lots of writing examples from someone, and it can suggest you how to write in their style. So again, if you like writing of some of the best science writers out there, you could potentially imagine an AI tool that could help you write like them, so help you write better maybe. And there are many, many other things you could explore and imagine. So this is one new initiative by Journalism AI. I think they're based at LSE, where it's basically journalists and academics, and they meet up and they discuss how AI and algorithms can help them develop new tools and do their jobs better. So I think that's a good example of how we should be thinking about how to collaborate and use AI to make our jobs easier and better. And now for the last part of my talk, I will just briefly talk about my own project at MIT, which basically tried to automate science news writing. And this is just a sort of, I guess, a scheme of how it would work. So the idea is that you would take a research paper, you feed it into the AI bot, a black box, and out comes a news article or a press release reporting on that paper in a jargon-free way. So I've collaborated with colleagues at MIT's department, and we published a paper last April, which was, I think, well, for me, quite interesting because it showed that you can do this. So we used science news articles from Science Daily, I think it was, and we used something like 60,000 examples, and we matched these science news articles to their research papers. And basically, we taught this algorithm how to, how to write science news, basically, how to recognize which parts of the paper are newsworthy and how to write about them in a jargon-free way. And this is a quote from our early version of the paper, where one of the authors said that we're observing a primitive form of reasoning within this model. So the idea was that this model wasn't just picking sentences at random, but it was actually understanding or appearing to understand what's important in this paper and how to present it. And this is just an example from that paper where, to the left, you have a science press release, basically, and to the right, you have the output of our algorithm. The one in red is a previous algorithm, which wasn't that great, and the one in green is ours. Which basically summarizes the story quite well. So this was the first step. We just summarized the whole press release in 2 or 3 sentences. And then the next step would be to take a full research paper and produce either a summary or a science news story. But I guess what this example showed us was that actually this might be possible. And we used a relatively small number of papers to train this algorithm. But the idea is that in the future, you would use more and make it even smarter. And, potentially with deep learning algorithms, you could have it learn as it does things, I guess. And so, we're not the only ones who are doing this. This is an example from UK Conference of Science Journalists a couple of years ago, where Sabine Loet from Ireland, she was presenting a similar algorithm that she uses to summarize research papers and to produce simple news stories. Again, her algorithm has improved a lot, and it does produce quite interesting results. So I think what both of these examples show is that some of the automation, the simple one, for producing science news and for producing science press releases is almost here. It works pretty well. But what does that then mean for us as science journalists? I think it's a pretty good business model for someone who just wants to produce lots of science news, because you could potentially, report on every single paper without employing a single science reporter. Does that mean that those science reporters who don't have to write press releases or short news stories, does that mean that they'll have more time to do other things like in-depth reporting and features? That's a big question. Or will they just be fired or not hired to start with? And what does it mean for entry-level jobs in the media? Because in science media, often the first job you get is as a science news writer. You write simple short stories, you report on single papers. And if AI can do this quicker and cheaper than people, then does that mean that those jobs will be gone? And what then happens a few years later down the line if our pipeline of new science journalists is not there anymore? I think that's the big question that, I can leave us with for discussion.
Thank you very much, Mico. Your presentation was a bit too long, but very, very interesting. And we are friends, so I pardon you. Anyway, I think this is a good introduction for Charlie Beckett, who has studied the issue from the, I think, complementary perspective. So with a wide global survey on the use and how the news media are currently approaching the use of artificial intelligence tools in the newsroom. Please, Professor Beckett.
Great, thanks very much. Yeah, I'm very much approaching this from kind of mainstream news perspective, not just from a science journalism perspective. I'm director of the journalism AI project here at the journalism think tank Polis, which is based at London School of Economics, which was referenced just now in Mico's presentation. So the points I'm making are drawn from our global survey of news organizations and from our continuing activities with this network of journalists who are using AI. The first point I want to make is that journalists will not be replaced by robots anytime soon. As Mico showed brilliantly there, most of the uses are supplementary to human editorial activity. Some of the marketing or personalization applications, they're more autonomous, and in the future perhaps we'll have more autonomous editorial production. But generally at the moment, and in the near future, AI technologies tend to augment or add to human editorial efforts. And this is very much in line with what Harry Collins was saying at the beginning about AI and science, that you need humans to check the data, not just to make sure they're accurate, but I think he made a very important point about that you has to be in this context that is ultimately political. So in our survey in 2019 of more than 70 news organizations around the world, they told us at least that their main motive in adopting AI technologies was to make journalists' work more efficient and more effective. The second most important reason was to connect that work better to audiences. And only the third reason was to make their business more efficient. And as Mico has just showed, the use of AI is right across the news production process. On our website, we have a directory of use cases that are incredibly varied. This technology is really a group of technologies. So you've got everything from bots that monitor editorial output to tools that can search vast data sets for investigative journalism. So all aspects of journalism can be involved: news gathering, news production, and the dissemination or marketing of that journalism. Some of the uses are very specialist, others have a much more systematic impact on the whole news flow. And that can mean very significant changes in the skill set of the journalists that's needed, or the practices of those newsrooms. And from this survey, we also learned that the adoption of AI is still relatively restricted. Mico had some great examples there of innovation, but it's not very well spread. And it's restricted by a lack of financial resource, above all, we all know about this, but also critically by lack of technical skills, knowledge, insight, and quite crucially, a lack of development capacity within news media, as well as the usual problems of resistance to cultural change. Now, although AI can be highly efficient and effective in specific use cases, generally at the moment, it still lacks the sophistication to handle much beyond basic functions. So AI does have increasing potential, but there are great inequalities of adoption between news organizations, most obviously between super big organizations like the Washington Post, New York Times, BBC, and smaller ones, but also, for example, between different national markets. And there are some very tough strategic decisions. Again, Mico mentioned one of them, about how you deploy AI, what happens when you do that, issues around bias, return on investment, or critically on the impact on editorial standards. And I think Mico made a very interesting point there as well about career development. So it's important to remember that compared to industries such as retail, security, pharmaceuticals, or fintech, the news media is pretty small, and it's lacking the financial resources to conduct the research and development needed, especially to make it applicable to the special use cases of journalism. And that's one reason why we are seeing that news organizations are increasingly interested in collaboration with each other, surprisingly, with tech companies, which is obviously a sensitive relationship, or even, of course, I'm pleased to say, with universities. So AI has demonstrated the potential to add significantly to editorial capacity, especially with tasks that involve scale and speed. But it requires a high degree of reflexivity from newsrooms, and those newsrooms are already, as we know, under massive pressures. On fact-checking and credibility in particular, AI offers very useful ways to handle information at volume and to contribute to moderation and validation, as well as helping to identify misinformation. It can also be used, though, to help counter human biases or errors as well. But currently, it definitely still requires significant human inputs. And I think that's a very good thing and should not change. We need to edit the algorithms just as we would edit any other form of journalism. So the hope is that if AI can do the more routine, commodity, or repetitive data labor, then that theoretically can at least free up time for the human journalists to concentrate on what they do best, which I would say are things like being creative, being emotional, making judgments, and perhaps above all, using their critical faculties. In the fight against misinformation, of course, that's absolutely critical. Much information is currently amplified and even created by human journalists because they don't have the time to check their own work, let alone check other information. AI may be able to help on that, or we know it can. So in summary, I would argue that the fears about algorithmically driven journalism are valid. We should pay attention to them, but I think they're currently overblown. I would suggest that from a news organization perspective, the real problem is going to be a failure to adopt and adapt and develop these technologies for editorial benefit. We are going to be in an increasingly algorithmically driven world, and we've seen the good and the bad of that recently, and it's vital that journalism understands what's happening. The news media has a key role, and I think science journalism in particular has a key role in investigating and monitoring these technologies, the companies that provide them, and the people that use them to create or access information. the news media has to be on board for the benefits, or it risks falling further behind competitors in this new information space. So a little bit of an advert for the work I'm doing. We've listened, through this survey to what the news organizations are telling us about AI, and that's why we're working so hard to find out what they do with it and what they need to meet the challenges. So we've created a couple of free online training courses that introduce journalists to AI and help them develop strategies of adoption. That's why we're running the collaboration experiment that Mico mentioned, where we have 40 journalists currently working there from around the world, coming up with prototypes for AI uses. And these have included promoting greater diversity, tapping into evergreen content, and helping to improve the experience of subscribers through gamification. We now have a network of more than 1,200 journalists in this network. They're around the world sharing best practice and their experiences, and you're all welcome to join that network and sign up for our newsletter. Just search Journalism AI Polis LSE and you'll find the website, where you can also find the report. There's a bibliography of resources and sources for the more academically minded, and there's a whole list of case studies from around the world. So I think it's important, it's wonderful that we're having this debate, because specific uses like fact-checking are really interesting, but I think it's important that we set it in the wider context of the state of the news media and how it's changing, and also the need for much more attention to be paid to this set of technologies that I think make up a kind of third wave of technological disruption and innovation for the news media. Thanks very much.
Well, thank you very much also for not only answering here, but providing a very useful answer to one of the questions that came from the audience. Rosie Delone asked, will science journalists now need AI training? And of course, your answer is, be my guest. So this is the hook to ask Professor Fabiana Zollo, who has been studying and publishing on also on the spread of fake news through algorithms, to go into the technical details of how do they work, what are the limits and limitations, what might be also alternatives in an additive approach to make our job more effective. Please, Fabiana.
Thank you. Good morning, everyone. My talk will briefly focus on some technical aspects and limitations of artificial intelligence methods for fact-checking, also for the automatic detection of what is commonly referred to as fake news. So I will try to summarize some of my thoughts on this in the following minutes. So let's start from the fake news. So if we want to detect fake news, first what we need is a definition of what fake news are. And this definition should be clear. So we know that the term fake news indeed is a term that brings under a single umbrella very different notions. So we can have disinformation, so the deliberate creation and manipulation and dissemination of false information with the aim of misleading audiences. But we also have misinformation, which is the unintentional spreading of false or unreliable information. So misinformation can also be any piece of news or information that later is proved not to be valid anymore. So in this time now, if we have this latter definition in mind, we can say that many news that were diffused during this pandemic can be now considered full-fledged misinformation because maybe that information was then proven to be wrong after the research of many scientists. So what I want to say is that if we want to, so it's complicated, and there are many shades, and this is especially true for scientific information, where we always have a certain degree of uncertainty and where knowledge is built piece by piece over time. So if we think at algorithms for fact-checking or for fake news detection, the definition of false, so what we consider false, where we start from, inevitably influences how the algorithm works, what it's looking for, and what it's ignoring. So we have to take this in mind when we interpret the results of an algorithm. So let's suppose that we have agreed on a certain definition of fake news, and we have an algorithm that is able to classify, let's say, unreliable or false information with a given accuracy. So this means that, of course, the algorithm is not perfect. So it may also lead to what we call false negative or false positive results. So if we have false negatives, it means that actual fake news are classified as reliable. When we have false positive, it means that we have reliable pieces of information that are instead classified as fake news. So in both cases, the algorithm is wrong. This aspect, when we interpret the result, and is often neglected. I mean, by the technicals or non-experts in the field, but it's an important one, because a false positive implies that good content is automatically classified as false or unreliable. And so this might result in censorship and de facto penalizing pluralism, which is, we know, vital in a democracy, and which was what we were trying to protect in the first place when we thought that we need an algorithm for classifying, for detecting fake news. So this is, of course, not only a problem of artificial intelligence. So we know that errors may also be human, and our judgments are strongly influenced by our opinions, by our worldview and biases. And here I'm coming to my second point. So speaking of biases, we know that artificial intelligence models rely on data. And if we have biases in the sample data, we will inevitably have a biased model in the end. So this is not nothing new in artificial intelligence. We can, for example, think at unfair and biased decision-making by algorithms against Black people, for example. But again, it's a crucial point that we have to keep in mind when we interpret the results of these models. So these results have to be taken with due caution. And just to conclude here, maybe, and this is my perspective, the problem of fake news detection is ill-posed. I mean, is it really possible to always discriminate between true and false? So where do we draw the line between the true and false? So if our aim here is to improve the information ecosystem, maybe we can have a different approach. So for example, what we did as a research group, so we are a research group, I would say, of data scientists, computation and social scientists. So what we did was we presented an early warning framework. So our idea was that if we can rely on data and use this information to determine in advance potential targets for hoaxes and fake news. And this was based, so it was a sort of prediction of future fake news topics, but was based not on the content of the news, but on how users are interacting with the content. So in terms, for example, of their behavior, the emotional behavior, their polarization, their sentiment. And so the idea is that if we have a system, for example, like this, we can for example, support newsrooms by raising warnings on sensitive topics that need to be addressed with caution to limit the spread of disinformation. So we are trying to prevent the spreading of disinformation in changing the techniques or the strategies, the communication strategies. And speaking on this, what we also did in collaboration with the London School of Economics and with Corriere della Sera, which is the main newspaper in Italy. So we tried to understand if some journalistic techniques and content types online are more effective to promote a civil and non-toxic debate about around controversial issues. So this is just, so in that project, we focused on the migration issue in Italy. It was really interesting also to work together side by side, the data scientists and journalists to understand what we can do to improve the information system and the way in which we debate on very controversial issues where misinformation is very likely to spread. And so I do believe that this collaboration with researchers and data scientists and journalists is really crucial and might allow for more effective ways to communicate this is just to say that technology itself is not something that we have to be afraid of. It's something that, as many before me said, can really help the system, but we have to be careful of the tools that we are using and what they really mean and how they work.
Thank you, Professor Zollo. I think that, I mean, from the perspective of a simple science journalist, it seems to me that Mico Tatalovic's work is very interesting in showing how computers can be trained, how algorithms can be trained to emulate the simplest tasks. So in a way, my question for the panel is there an essential difference when it comes to producing new acts by AI when it comes to spotting something which is clearly wrong on a controversial topic, and on the other side, it's producing something very, very simple. I have a personal, how can I say, fight with the simplistic view about fact-checking. I still wonder what is worth checking and what is worth calling a fact in a very long and complex story on a newspaper. Because I wonder how much agreement there is between professionals. Then, of course, if you have to look for the date of birth of someone, it's quite simple. But to decide that that person is relevant for the story is a whole other kind of question. So I would now introduce a question from the audience. It was written when Mico was speaking, and it might introduce maybe a round of opinions on the wider question. So the question is, how did you collate feedback for the AI written articles? It comes again from Rosie DeLone. And you can write your questions in the Q&A section for me to ask the speakers if you want. Please, Mico, can you answer the question?
Yeah, so if I understand the question correctly, feedback on the output was, well, it just like we read what it produced and then looked at whether it made sense and whether it represented the paper well enough. So I think that's the idea. So, you know, I think in this field you really need collaboration between journalists and academics and developers who understand the AI side of things. And as science journalists, I think we bring the expertise of knowing what a good story is or how you report on a paper, what's important. So I guess that was my part of the, that's where I came in to kind of help understand, what would be a good science story. So I think in this case, we were just looking at whether it can produce something that makes sense and that it represents key findings in a simple way. So, this was like one of the first steps in this procedure. And then also, you look for jargon, you look at whether it can simplify language the same way that science writer would do, right? So you wouldn't use some of the complex wordings that are in a paper when you write your story. So in the same way, you're kind of expecting that from your algorithm as well. But we haven't done like, surveys of people and what they thought of the output. We just kind of relied on our own judgment about what a good science article would be.
So maybe the wider question is partly already answered by Professor Beckett, which is how much of the use in the newsroom can we expect to be as a tool for humans, and how much as an independent producer of part of the work, which is in a way the false positive and the false negatives that Professor Zollo was mentioning, has not yet been, I think, measured for bots producing news. So how many times you agree as a human that the robot did the good, produced a good story and found the relevant part of the story and selected the right numbers. So maybe that's in the end we will have two different uses. One to defend from bad news through the intervention of humans. How much the intervention of humans will have to be trained? Maybe that's another kind of question. Please, Professor Collins. You need to unmute, wait a second. Please go ahead.
I'm kind of reassured by most of the talks here because of the fact that people realize that AI can be used, but only when in interaction with humans. Mico's talk I found a bit more disturbing because it felt to me a little bit like the tradition of MIT Artificial Intelligence Lab, which uses terms like this machine understands or does the same as a journalist rather too easily. I mean, a tradition going right back to Marvin Minsky. And I think you've got to be very careful with that kind of talk. I mean, at one point in your talk, you said, this will enable journalists to write news stories without any scientific understanding. Well, I think you've got to be careful about saying things like that without really thinking about what that means, what scientific understanding means. Now, I'm going to make a positive suggestion that when anybody says anything about the role of AI in science and science journalism, they should keep three things in mind. One, within science itself, there's a continuing problem about establishing the borderline between science and the fringe of science. And you can't establish this borderline by looking at people's qualifications. There is a huge and flourishing fringe science that, for example, supports people who don't believe in the theory of relativity. And these are people working in universities with often very, very, very clever people. You can see this in, say, Thabo Mbeki's claim that antiretroviral drugs in South Africa were dangerous and harmful. One of the people supporting Thabo Mbeki was a Nobel Prize winner. You're not going to be able to do it by simple demarcation criteria like that. Science is continually establishing and re-establishing this borderline, and you can't expect an AI to somehow cope with it. Similarly, the second thing I'd suggest everybody keeps in mind is that there's you can draw a logistic graph of citations. And if you take this as meaning anything, it's only a very few papers that get published in scientific journals that are really important. And 90% of papers are either never read by anybody or probably, well, 50% are probably never read by anybody. 90% are mostly ignored. And most of that isn't important science. Well, okay, there's no harm if some algorithm is producing an account of these things, but there's a sort of myth that artificial intelligence, because it's capable of reading all the scientific literature, whereas scientists themselves don't have time to read all the scientific literature, artificial intelligence will produce better science. But the scientist's problem is to know what not to read, not what to read, and not how to read more and more and more. And the third thing I'd say to keep in mind is just think about how journalism handled the revolt against mumps, measles and rubella vaccine, and how AI would handle it. So those are three sort of concrete suggestions about how to think more carefully about these things so that one isn't tempted to give easy answers.
Can I just briefly respond to those couple of points?
Okay, then Professor Beckett also wanted to answer or to comment.
Yeah, I think just a couple of points. So the thing about the language and the MIT tradition, I guess this is one of the reasons why it's important, I think, for journalists and science journalists to engage with this and be a part of the conversation and collaborations, because otherwise, if you leave it to the developers, to the scientists, they will take it in the direction that's interesting to them, and we will end up with solutions and technologies that are not necessarily those that we need or that we agree with. Because I think this is an area of science, research and development that is happening with or without us. But I think I've used that quote, which actually didn't make it through the peer review. It was in the early stages of the paper, just to demonstrate how, I guess, how some of these PhD students and researchers think and what they expect from this, right? So they are kind of thinking and expecting it to reason and to understand stuff. So it's not just some simple, I guess, simple software that they're aiming to get. And I don't think I said that it would allow you to do stuff without understanding science. I guess the point I was making there is that things like Science Surveyor, software like that could help journalists who don't have expertise in a particular beat of science, help them report on it better, because it would alert them to the issues such as, is this a marginal view in science or not? How many other papers on this have been published recently? Has this group published on this before? So I think software like that would kind of allow you to report on things that you're not necessarily comfortable or you don't know much about. And I think that's not that different from a lot of science reporting that goes on now, because a lot of science journalists report on lots of things that they don't know much about, and a lot of journalists report on science that they don't know much about. So I think this is, I guess this is a way of helping journalists report on science better, in a better quality way. So I guess that's what I was trying to say. Maybe I didn't express it that well. So I wasn't saying that it will allow you to do stuff if you don't know anything about science, but help you get into science reporting and do your job well, because it will be able to hopefully give you that context that you might not know as someone who hasn't covered a beat before.
Thank you. We are approaching the end of our time slot. So please, Professor Beckett, if you wanted to add something on the issue.
Yeah, just very quickly, just to say, I think this is getting to the heart of, this is a debate about AI, but it's also a debate more generally about, data and science. When the MMR autism story broke, whenever that was, 20 years ago, first in the UK, I was a program editor at Channel 4 News, and we misreported that story in the sense that we went with the original report, which claimed a link, and by the end of the week we had to backtrack and we realized we'd made a dreadful mistake. So there was a clear case, as Mico said, most science stories are actually reported by non-specialists to a degree, and we've seen this absolutely with the COVID story, where we've seen some fantastic journalism where people are grappling with these statistics and coming to an understanding that the scientists themselves disagree. So it's absolutely vital to have this debate, and I agree with Mico that handled well, AI can help a lot on this. I think one of the problems here is, very briefly, is this idea that of the article, that we're going to create an article. I think AI can actually help in many other ways when we're doing our journalism. From the journalist point of view, it can help you find better resources. Instead of just going to your usual go-to commentator, you can actually find better, more relevant, more diverse sources of information or commentary, for example, but also from the audience point of view. There's no point creating a beautifully sculpted story. As Harry said, there are people out there who are coming to a topic from a completely different perspective. So again, machine learning AI helps us understand who is consuming this material, how they're doing it, and possibly offering ways to tailor that content so that you're able to connect the better version of it to those people. So I think this is a great debate to have, and it's not just about AI, it's not just about science. It's about accepting that journalism has always been imperfect, it's under a huge amount of pressure now, and in some ways, used critically, these technologies might be able to help.
Thank you very much. There was a question from the audience about the impact of social media in the spread of fake news, and I see that Professor Zollo would like to answer, but I think that would open a whole new debate. It's of course a huge impact that it is having. I wanted to conclude with a question from James Dacey from the audience, which I read. I lost it, but the question was, okay, Mico Tatalovic already answered in writing. The question was about the impact on trust, and you can read the answer in the Q&A chat line. I want to thank you very much, all of you, for being here with us. I think it was very useful. I'm glad that also Professor Collins shared my fears that were in a way reassured, and I'm glad to know that there are several people at work, and I suggest, and I will have to look immediately at the training courses organized by the Polis, by Charlie Beckett, and I suggest we will probably put something on it in the conference website. So thank you very much, everyone. I ask our audience to stay with us. In 10 minutes, less than 10 minutes, we will have a very interesting roundtable with a very practical approach on the COVID-19 situation and how to deal with uncertainties and politics with a very interesting lineup of science journalists, mostly from all over the world. So thank you very much again, and see you all in a few minutes.